Welcome to this Edexcel June 2018 Higher Paper 1. So we're going to go through this today, and Happy New Year if you're watching today. So let's start this. Question 1a. We've got a mixed fraction, two mixed fractions, and we're asked to add them. So let's first change them into improper fractions. So 2 and 1/7 becomes, 15/7. Remember, we do the 2 times 7 and add 1. The 1 and 1/4 becomes, 1 times 4 is 4, plus 1 is 5, so 5/4. Now, how do we get these to the same denominator? Well, we need a number that has 7 and 4 as factors, and we can change them both into 28 by timesing this one by 4 and this one by 7. But this means we need to times the tops and bottoms by these numbers. So 15 4s are 60 over 28, and 5 7s are 35 over 28. So this is 95 over 28. Now we can change this into a mixed number if we want, but I'm fine with that. Okay, question B. Work out 1 and 1/5 divided by 3/4. So 1 and 1/5 equals 6/5, and now we can do 6/5 divided by 3/4, and there's a nice easy rule for dividing fractions. You flip the second fraction and change the sign to a multiply. So this becomes 6/5 times 4/3, which equals 24 over 15. And it says to give your answer as a mixed number, so this is 1 and 9/15. And does that simplify? Yeah, the 9 over 15 simplifies to 3/5. So our answer is 1 and 3/5. Okay, great. Question 2. In a village, the number of houses to the number of flats are in the ratio 7:4. So let's write that down. So H to F is 7:4, and also the number of flats and the number of bungalows are in the ratio 8:5. What else are we told? We're told there are 50 bungalows in the village. So we know if we can make this 5 into a 50 now, that we will have the correct number of bungalows, but when dealing with ratios we need to do whatever we do on one side, we need to do on the other. So to make 5 into 50, we need to times by 10, which means we also need to times the 8 by 10. So we get 80 to 50. So now we know how many flats there are in the village, 80, which means we need to make this into 80 by timesing by 20. But that means we also need to times the number of houses by 20. And so we see that the number of houses is 140. Okay, question 3. Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. She puts all the sweets into bags. She puts 250 into each bag and sells each bag for 65p. She sells all the bags, work out her percentage profit. So first we need to look at, how many grams are there in 5 kilograms? Well, that's just 5,000 grams. Yeah, there's 1,000 grams in a kilogram. Right, and we need to see how many bags she sold. So we need to do 5,000 grams divided by 250 grams. This is the quantity of each bag. And this is all sweets. Right, and then if we do this division, this is 500 divided by 25, which is 20. So she sells 20 bags. Right, we know she sells them for 65p. So we do 20 times 65, or 0.65. What does this give us? This gives us 13. Yep, so 20 bags times the price of the bag price of bag. And this gives us £13. So we know she's paid £10 for the sweets. So paid £10, sold for £13. So you should be able to see that this is a 30% profit. Yeah, because you take the profit, which is £3, and you divide by 10. This is 0.3, and there we go. So the answer is 30%. Okay, question 4. A cycle across America is this number in length, 3069.25. His average speed for his previous races is 15.12 miles an hour. For the next race, he will cycle for 8 hours per day. So let's work out what is how much he does in one day. So let's have a look. So, and it also says estimate how many days it will take Joanne to complete. So let's estimate how much he does in one day. So in one day, well, he's averaging, let's say, 15 miles an hour, and he does 8 hours a day. Uh, 15 times 8 is 120. So he's averaging 120 miles a day. Again, we're estimating, so let's change the 3069.25 into 3000, and we're divided by 120. So we can cancel off a 0. 300 divided by 12 is the same as 150 divided by 6, which is 75 divided by 3, which is 25. So our estimate is 25 days to complete the race. Okay. Joanne trains for the race. The average speed increases. It is now 16.27 miles an hour. Well, his average speed has gone up, which means he's going to do more miles in the day, which means it's going to take him less days. So, less days to complete the race, i.e. estimate will go down. Okay, and that's that question. Right, here is a solid square-based pyramid, VABCD. The base of the pyramid is a square of side 6, so that's here. The height of the pyramid, so that's from the middle of the square to the top, is 4, and M is the midpoint of BC, so that's here, and VM is 5. So draw an accurate front elevation of the pyramid from the direction of the arrow. So that means looking at it from here. So let's do that. Well, we know the bottom is going to be AB, which is 6, so let's count that. So 1, 2, 3, 4, 5, 6. And again, you should use your ruler. I'm just doing this freehand. Right, we also know the height up to V is 4 centimeters, and when we're looking, that's going to be in the middle of AB. So that's here. That's 1, 2, 3, 4. And that was our point V up there. Right, and then finally we've just got to connect up the sides. Something like this. Again, use a ruler. It should look something like this, with hopefully straight sides. So maybe we can put a few measurements on. This is 4 centimeters, this is 6 centimeters, and so on. So that's fine there. Right, work out the total surface area of the pyramid. So let's go back. Well, we can do the base for starters. Yeah, the base is going to have 6 times 6 area. So base 6 times 6, which equals 36 centimeters squared, because it's just a square. And then we have 4 identical sides. And what do the sides look like? Well, there's 6 centimeters. Along the bottom, we don't really know what these sides are. We need to work out this height. And if we go back to our diagram quickly, so I'll draw on the side we're looking for. So we're looking for this height here, right? And we're going to do it using Pythagoras. So let's have a look at this line. And now we have a right angle triangle here. So we know this is 3 centimeters because it's halfway from the edge of the square into the middle. We know the height is 4 centimeters. So we have a right angle triangle, which I'll draw out here, where this side is 3, this is 4, and this is the height we're looking for. By Pythagoras, h squared equals 3 squared plus 4 squared. And so h squared equals 9 plus 16, which is 25. And so h equals 5. So we now have the height of each of these triangles, these ones here. So we know that h now equals 5 centimeters. Area of a triangle is half times base, which is 6, times the height, which is 5, which equals a half of 30, which is 15 centimeters. And we have 4 of these. So we do 4 times 15 equals 60 centimeters squared, that should be. Okay, great. So now we just have to add these. 36 centimeters squared plus 60 centimeters squared. And this gives us our final answer. Total surface area of the pyramid as 96 centimeters squared. Great. Okay, question 6. A pattern is made from 4 identical squares. The fact that they're identical is really important. The sides of the squares are parallel to the axes. So let's have a look. We start at A, 0.67 here. We're given what B is, 38, 36. We're asked to find C. Okay, so let's have a look. Let's see how far along we go in the x direction. So this way. And how far up we go in the y direction. So this way. Well, to get from 6 to 38, we go 32. And to get from 7 to 36, we go 29. So that's just looking at the difference between B and A there. Now, along the bottom, we just go along 4 sides of the square. So we go along here, along here, go along here, which tells us that the side of the square must be 8 centimeters. Yeah, but that also means the height is 8 centimeters. So this is 8, 8, 8, and so on. Yeah, 8, 8, and 8. So we can work out the x-coordinate of C. So I'll change colour. So to get to C from A, we start at 6, we go along 8, and we go along another 8. So x-coordinate of C is 6 plus 8 plus 8, which equals 22. Yeah. So C occurs at position 22. Right, how do we find the y now? Let's have a look. We start at 7, we go up by 8 to get to here, and if we go up another 8, then we end up here, which is too far. But we need to look at how far we've gone up in total. So let's move backwards. So if we start at 36 in the y, go down 8, we get to here, which is 28. Go down another 8 to here, we get to 20. But again, we've gone too far. And if we go up here, we get to 15, up here to get to 23. So this must mean that this little area here is 3, which makes this 5. So how do we know that? Well, if we start here and go up 8, we get to 23. Whereas if we start here and go down 8, we get to 20. So now we're ready to work out the y coordinate. And we do that like this. The y coordinate of C is, well, we start at 7, we go up 8, and we go up another 5. So that equals 7 plus 8 is 15, plus 5 is 20. So our final answer, coordinates of C, are 22, 20. Okay, question 7. Here we have a shape T. So shape T is reflected in the line x equals 1 to give shape R. Shape R is reflected in the line y equals 2 to give shape S. Describe the single transformation that maps T onto S. So T is reflected in the line x equals 1. It's this line here. Again, make sure you use a ruler, not like me. Right. So this point is 2 away. This point is 1, 2, 3, 4, 5 away. 1, 2, 5. This point is 1, 2, 3 away from the line. So 1, 2, 3. Again, use your ruler to connect it up, but you get the general idea. So that's shape, what do they call it? Shape R. Right, and then shape R was reflected in the line y equals 2, minus 2. So that's this line here. Okay, so let's reflect this. Starting with this point, it's 1, 2, 3, 1, 2, 3, 1, 2, 3. And finally this point, the top point, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so now again, connect that up. So that's shape S. Okay, the question, describe the single transformation that will map T to shape S. There's actually two answers here. One is a rotation and one is a reflection. I think I'm going to stick with the rotation because that's sort of easier to visualize for me. So if you notice, T rotates this way and it's going to go 180 degrees because the top ends up on the bottom and it's clockwise. So the answer, rotation, 180 degrees, clockwise, and the center is -1, -2. Okay, so the other answer would be an enlargement. Okay, question 8. The perimeter of a right angled triangle is 72. The lengths of its side are in ratio 3 to 4 to 5. So if it's in 3 to 4 to 5, this means there are 12 parts just by adding them together. So if we do 72 divided by 12, this gives us 1 part, and this is just 6 centimeters. So now all we have to do is multiply each of the ratios by 6. So 3 times 6 is 18. That's one side. 4 times 6 is 24. And finally 5 times 6 is 30. So we have a right angle triangle that looks something like this. This is 30, this is 18 say, and this is 24. Area of this triangle then is just half base times height. So a half times 18 times 24. So this is just 9 times 24. And how can we work this out? We can do it a few ways. Well, 20 times 90 is 180. 4 times 9 is 36. Adding these together gives you 216 centimeters squared. And that's the answer there. Okay, question 9. We've got some indices, and hopefully you've watched my video on indices I did the other day. So if we have 36 to the half, then this is just the square root of 36. And this just equals 6. Okay, 23 to the 0 equals 1, as anything to the power of 0 is 1. And finally, this is one of the examples we did the other day as well. So 27 to the minus 2/3, well, we use the reciprocal. Right. So anything to the negative power is just the same as 1 over that. And 27 to the 2/3 is just the cube root of 27 squared. We know the cube root of 27 is 3 because 3 times 3 times 3 is 27. So this just equals 1 over 3 squared, which equals 1/9. So our answer is 1/9. Okay, the table gives some information about the heights of 80 girls. Least height, greatest height, lower quartile, upper quartile, and median. So let's put these in. It wants us to draw a box plot, so that's what we're going to do. So the least height was 133, which I'll draw in now. About there. The greatest height was 170, so that's there. Okay, the lower quartile, 145. The upper quartile, 157, which is there. Again, make sure you're using your ruler for this. And the median, 151. Now it's just a case of neatly drawing these up, as so. Which is harder than it looks. There we go. So that's our sort of shoddy looking box plot now. Okay. Work out an estimate for the number of these girls with a height between 133 and 157. So 133 is our lowest, and 157 is our upper quartile. So this means we're looking at, well, we know the upper quartile is sort of the 3/4 point, so we're looking at the upper quartile to the first value. Which means all we need to do, we know there's 80 girls, so we just need to do 3/4 times 80. And this just equals, well, if we multiply, it's 240 over 4, which equals 120 over 2, which equals 60. So 60 girls is our answer. Okay, question 11, we've got a circle here. A and B are points on a circle centre O, BC is a tangent, AOC is a straight line, and angle ABO is X. So let's draw that one in. That's this one here. Okay, find the size of angle ACB, which is this one, in terms of X. Give your answer in its simplest form. So let's have a look. Well, okay, OA and OB are radii, which means they have the same angle. So this is also X. Right. Now we can see that this angle here, which I'll do in a different colour, is 180 take away 2x. because so we have this triangle here, A, B, O. This is x, and x plus 180 minus 2x equals 180. We know that angles in triangles have to add to 180. So that's our angle AOB. Maybe I'll write that in. Angle AOB equals 180 minus 2x. Remember, this symbol just means angle. Okay, well now we can work out this angle here. And this is just, well, 2x. Because angles on a straight line have to add up to 180. And 180 minus 2x plus 2x is 180. Finally, we know that BC is a tangent. So if we have a radius, OB, then this angle here must be a right angle, which is 90, of course. Okay, so we're good to go. So angle, again, we know the angles in this triangle, OBC, need to add up to 180. So angle ACB, the one we're looking for, equals, well, it's 180, take away, and it's the sum of the other two angles, 90 plus 2x. Okay, simplifying this, we're just going to get 90 take away 2x. So, maybe given some reasons, these two are radii, that's fine. This angle is 90 as BC is a tangent. So what else have we got? Angle AOB is 180 minus 2x as angles on a line. Okay, and I think we're probably good there. So I'm not putting in every single reason. I'm hoping you'll be able to do that for yourself, but I'm just giving you the rough ideas. So that's our answer, 90 minus 2x, and that is in its simplest form. Okay, question 12. We've got a prove question here. So whenever you see a question like this, you need to start with an assumption, go through some logical operations, and try and show the outcome. So the square of an odd number is always one more than a multiple of 4. So, odd numbers, we normally look at numbers of this form, 2n plus 1. Yeah, if you put in any number for n, this will always give you an odd number. And we're looking at that number squared. So, we can expand this normally, as so. So this is going to be 4n squared plus 2n plus 2n plus 1. Simplify this a little bit. 4n squared plus 4n plus 1. Now we can factorize anything with a 4 in it. In fact, we can take out a 4n to leave 4n on the outside, n plus 1. We've got 1. So, this thing here is a multiple of 4. And so the whole thing is a multiple of 4 plus 1. And look, that's exactly what we were trying to prove. The square of an odd number is always one more than a multiple of 4. So we're done there. Okay, question 13. This expression here can be written in the form a root 10, where a is an integer. Find a. So, a few ways you can go about this, but I'm just going to expand it straight away. So this expands to root 5 times 8 plus root 5 times 18. 5 8s are 40. Okay, and now we can simplify this to root 4 times root 10, root 9 times root 10. Remember, when simplifying surds, you're always looking for a square number you can pull out. Square root of 4 is 2, so this becomes 2 root 10. Square root of 9 is 3, so this becomes 3 root 10. And so we have 5 root 10 in total. Don't forget, it says find the value of a, so our answer in this case is going to be 5. Okay, a nice inverse proportion question. Let's have a look. Y is inversely proportional to d squared. which means y equals some k divided by d squared. And it says when d equals 10, y equals 4. So let's plug these in. So 4 equals k divided by 10 squared, which implies 4 equals k over 100, and this implies k equals 400. So we can now write our new expression, y equals 400 divided by d squared. Okay, let's look at the next part. D is directly proportional to x squared. Well, this just means d equals some, let's call it L times x squared. Remember, we don't want to use the same k, as we might get confused with this one. So d is directly proportional to x squared, which means d is some multiple of x squared. And we're told that when x equals 2, d equals 24. So let's put that in. So 24 equals L times x squared. And so 24 equals 4L. Therefore L equals 6. 24 divided by 4 is 6. So now we can write d equals 6x squared. Okay, and the question, find a formula for y in terms of x. So let's have a look. Well, we know that y equals 400 over d squared. Yeah. But we now know what d is. Well, it's 6x squared. So squaring that, 6x squared, gives us our final answer of 400 divided by 36, x to the 4. But in our question, it says give your answer in its simplest form, so we need to simplify this. We can divide both by 4 to give 100 over 9x to the 4. And that is our final answer. So y equals 100 over 9x to the 4. Okay, factorize a squared minus b squared. Well, you should know this is the difference of two squares. So I'll write that down. It's a very important part of mathematics. So a squared minus b squared can be factorized to a minus b times a plus b. Right, and if you don't believe that, just expand those brackets and have a go. Okay, so it says, hence or otherwise simplify fully this. Now this is our a, and this is our b. So what did it factorize to earlier? Well, it was a plus b times a minus b. So x squared plus 4 plus x squared minus 2. And we're multiplying by a minus b. X squared plus 4 minus x squared minus 2. Okay, and we just got to simplify that and expand it. Well, this is going to be 2x squared by adding them, and the plus 4 and the minus 2 is going to make a 2. This is going to be, well, the x squareds are going to cancel. 4 minus minus 2 is 6. Okay, and then we just expand this. We get 12x squared plus 12, and we can factorize 12 from this to give 12x squared plus 1. And that is our final answer there. So I'll write it out again. Great. Right, there are only red counters, blue counters, and purple counters in a bag. The number of red to the number of blue is 3 to 17. Sam takes a random counter from the bag. The probability that the counter is purple is 0.2. Okay, before we do this, it might be worth working out how many purple counters there are. You don't have to do this, but this is the way I like to approach these questions. So red to blue to purple. Red is 3, this is 17, and let's call purple X for now. Okay, Now we've been told that the probability that the counter is purple is 0.2, or 1/5. So, but we also know that this is equal to x divided by 3 plus 17 plus x. Yeah, we're just taking the probability of purple there. Now we can simplify this a bit. So it's x divided by 20 plus x equals 1/5. And now we can cross multiply. So we get 5x equals 20 plus x. And this tells us that 4x equals 20, and so x equals 5 there. Okay, so let me clean this up a bit and then we'll go through the final answer. Okay, so work out the probability that Sam takes a red counter. Well, we just need to do, so I'll put probability of red equals 3, and we've got to add them all up. 3 plus 17 plus, we now know x is 5. So this equals 3 divided by 25. Multiply both sides by 4 to get it over 100. And then we can see this is 0.12. So I like to keep probability in the same form it gave us it. So it gave us it as 0.2 here. So that means I wanted to keep it in a decimal again. Okay, great. Right, simplify fully this. So the first thing you should know is that 3, or the coefficient of x squared here, is a prime number, which means that the brackets can only be split up in this way. Yeah, if we had, say, a 4 there, you could split it up into 1 and 4, or 2 and 2. So now we're looking for two numbers that add together to make this, and multiply to make this. So add to make -3, and multiply to make -8. So hopefully after a little bit of looking at it, you can see 3x times -3 is -9x, and then if we put a +1 here, we get the required answer. So 3x squared plus x minus 9x minus 3. So that's how we do the top one. And the bottom bit, 2x squared minus 6x, well, we can take a factor of 2x out to leave x minus 3. Let's just check that again, 2x squared minus 6x. So now we can rewrite the whole thing. So it's 3x squared minus 8x minus 3 divided by 2x squared minus 6x. We factorize this as 3x plus 1 times x minus 3, and this was 2x times x minus 3. Okay, now we can cancel these two terms, and we're left with 3x plus 1 divided by 2x. So that's our final answer. Okay, question 18. Here is the graph of sine x for between -180 and +180. On the grid, sketch the graph of y equals sine x minus 2. So this is a translation in the y direction, -2 units. This point at the origin is going to go down to here. So 90 and 1 is going to go down to 90 and -1. So that's here. 180, 0 is going to go down to 180 minus 2. This point here, -90 minus 1, is going to go down to -90 minus 3. And this point, -180, 0, is going to go down to -180 minus 2. Okay, so now it's just a case of drawing these lines up with a nice smooth curve. There we go, so hopefully it looks something like that. And maybe I'll just write down the coordinates as well. So this is the point 90 minus 1. This is the point 180 minus 2. This is the point 0 minus 2. This is the point -90 minus 3. And finally, this is the point -180 minus 2. So that is the graph of y equals sine x minus 2. Okay, question 19. The point P has coordinates 3, 4. The point Q has coordinates AB. A line perpendicular to PQ is given by the equation 3x plus 2y equals 7. Find an expression for B in terms of A. So, let's first find the gradient of PQ using these 2 points. So remember, I'll just write down what we're finding. Gradient of PQ, and this is y2 minus y1 over x2 minus x1. So b minus 4 divided by a minus 3. Yep. And then we have this line perpendicular to PQ. Let's rearrange this so it's of the form y equals something. So this is y equals minus 3x plus 7. And so it's y equals minus 3 over 2x plus 7 over 2. Okay, because this line is perpendicular to PQ, and this is my little symbol for perpendicular to PQ, we must have that the gradients multiply to minus 1. So I'm going to write this as m1, m2 equals minus 1, where m1 is the gradient of PQ, and m2 is the gradient of this line. What was it? 3x plus 2y equals 7. So, where can we go from there? We know that m2 is this value here. I'll change pens. So it's minus 3 over 2, which implies that m1 equals 2/3, because we know that 2/3 times minus 3 over 2 is minus 1. Okay, we're nearly there now. We've also shown that the gradient of PQ, so maybe I'll write which equals gradient of PQ. We've also shown that the gradient of PQ is this value here, b minus 4 divided by a minus 3. So we can set them equal to each other. So b minus 4 divided by a minus 3 equals 2/3. And now we just got to rearrange a little bit. So I'm running over the page here, but that's not too much of an issue. Cross multiplying gives us this. So 3 times b minus 4 is the same as 2 times a minus 3. So 3b minus 12 equals 2a minus 6. Remember, the question wanted a formula for b in terms of a. This gives us that 3b equals 2a plus 6. And so b equals 2/3 of a plus 2. And that is the final answer there. So hopefully that makes sense. We just used the fact that the line is perpendicular to PQ and that the gradients have to multiply to minus 1. That was this part. Okay, moving on to the last question, I believe. Right. N is an integer such that 3n plus 2 is less than or equal to 14. And we also have this. So let's have a look. Well, 3n plus 2 is less than 14. This tells us that 3n must be less than 12, just taking 2 off both sides there, which tells us that n is less than or equal to 4. So that's our first bit of information. Moving on to this second part, it's going to give us a quadratic. 6n over n squared plus 5 is bigger than 1. Well, this tells us that 6n is bigger than n squared plus 5. Now, the reason this hasn't changed the sign is because the bottom is always positive. Hopefully you can see that. Okay, so let's solve this. Well, we can rearrange this as n squared minus 6n plus 5 is less than 0. And we can factor this as n minus 5, n minus 1 is less than 0. So we can draw the quadratic of this. So it's going to have roots at 1 and 5. So that's here and here. So the quadratic's going to look something like this. And we want where it's less than 0. So that's in here. So where is that less than 0? Well, it's below the x-axis. Okay. So we know that n must be bigger than 1, but less than 5. But from earlier, up here, we also know that n is less than or equal to 4. So let me write that in as well. And n is less than or equal to 4. So that means our only possible values for n are 2, 3, and 4. Because, well, n is an integer, so a whole number. N can't be 5, because it's less than 5. It can't be 1, it's bigger than 1. So it has to be 2, 3, and 4. And that is the end of this paper, guys. Hope you've enjoyed. Thanks.